So let's talk angles today. More specifically, we are going to talk about parallel lines and a transversal. Now, the terminology, simply a transversal is any line that cuts through two or more lines. So what you can see here is we've got parallel lines that are going to continue on and never meet, and then a line that kind of cuts through. Now, what's the purpose of this? Well, what if we were to give you one angle on here and expect you to figure out what the rest of the missing angles are? So let's just hypothetically say that this right here is 70 degrees. So if we know this one angle, we can solve for every single other angle in this transversal simply by using supplementary angles. Now that might be a term that's a little bit foreign to you, but a supplementary angle is simply any angles that when added together equal 180 degrees or a straight line. So if you take a look here, if I have this, which is a straight line, and I split it in half, I've got a 90-degree angle here and a 90-degree angle here. If I take this 90 degrees and add it to this 90 degrees, I get this semicircle right here, and this is a straight line. That's how many degrees I've traveled. So this is a supplementary angle, is what this is called. And if you take a look at our shape, if we go back to the shape, you can see that we have supplementary angles everywhere on the shape. This is a straight line, this is a straight line, and this is a straight line as well. So it allows us to take a look at this shape, and as long as we can remember that we have straight lines, we'll be able to solve everything that we need to know. Remembering that a supplementary angle is 180 degrees, let's figure this out. So if we have 70 degrees right here, and let's say we want to know what this missing angle is right here, because this right here is a straight line, if this is 70 degrees, then if we add 110 degrees to it, it will be 180 degrees or create this straight line. Now, interestingly enough, if we have a line that is intersected by another line, often what will happen is we have opposite angles. And these opposite angles are just kind of crossing the vertex right here. So if this is 70 degrees, then this angle has to be 70 degrees as well. And if this is 70 degrees going this way now, then this has to be 110. So there is a relationship between what we see here. Now, do you see another relationship? Because there is another relationship. What if I was to circle this right here and circle this right here? Do you notice anything different or anything similar? Well, it just so happens that because this is a straight line and it is not actually intersecting at any other point and not being curved, we know that these angles are going to be exactly the same as these angles right here. So if this was angle A and this was angle A, that means that this also must be angle A and this must be angle A, or in this case 70 degrees and 70 degrees. Now we'll do the same thing. If this was angle A, then these must be angle B, and if we look at angle B, this has to be angle B and this has to be angle B, and they are exactly the same. These are corresponding angles. So this must be 110 and this must be 110. And if we take and add these numbers together, no matter which way we're going on these straight lines, we will have 180 degrees. So if we take 110 and add it to 70, that's 180 degrees. If we have 110 degrees here, and we're missing this 70 degrees, then this right here, this line right here, would be 180 degrees. And then if we were working backwards, you would see that we end up with the exact same angles. So this is taking a look at interior angles of these shapes, looking at something called supplementary angles. And if you have any questions, by all means, pause the video, rewatch the video, or comment below. Thanks for watching.